My name is Thomas, and I've been in the Power Platform space since 2014 when Project Sienna was introduced, that is now called Canvas Apps. And I used to be a .NET developer, so I brought with myself a lot of tools and workflows that I'm trying to apply in this platform. And I would like to share with you some tips today, what works for me and my team, so you could possibly get inspired with some tweaks and scripts that we have created to better automate lifecycle management of our Power Platform solutions. So since this is a level 300 session, I expect that you have got some experience with Power Platform, specifically with solution framework. You are familiar with the need and the problem of moving solutions across environments, and you are working on apps which are from the important bucket, not the team productivity and personal productivity scenarios, because the things I will be showing, I'll be talking about today, they're not relevant for like simple personal productivity scenarios, because these don't need such a level of robustness when it comes to the DevOps process. So I have presented this for 10 times already. And actually, my first session on this topic was here on DynamicsMinds 2 years ago. And since then, some things have developed on Microsoft side. But since then, we needed to build some tools to do some plumbing in our DevOps process, because we serve tens of customers, and we usually work on highly critical applications. So we need to be very deterministic about our change management process and release management process. So that's why we started looking into these areas. As I presented back then, even today, I don't have a complete, fully functional, replicable solution for you, but I have took some of the code that we use internally and polished it out and published it on GitHub. So you can inspect my repos for MS build targets. These help you automate your build process and customize the default behavior. And I also started publishing some .NET templates, which can let you scaffold components locally without going to the runtime, to the browser, and doing it directly in the environment. This is, of course, not officially supported by Microsoft, so treat it like that. And I have also created a repository with all the snippets that I will be presenting today, and you will be able to replicate what I'm showing here if you want on your machines yourself. So I think what I will be demonstrating can be useful for automating the whole process. So I've also started looking into how I can contribute my agent to GitHub Copilot through a VS Code extension, or how I could wrap this process into an MCP server, because that's what everyone does these days, right? So what has changed recently? Now we've got native Git integration in Power Platform, and it is generally available now. We also have in-product pipelines in Power Platform, so we can get some sort of a CD process natively. And we now see a lot of tools helping us speed up the development process. Last week on Build, Microsoft has introduced 3 new runtimes, how you can wipe code your own thing and host it on Power Platform. So a lot more custom code will be coming to the platform, and will make this even more complicated. So we're shifting focus from apps to agents, at least from what you hear everywhere here on the conference and on all the Microsoft events. I still think that it doesn't matter if I build an app as a UI or an agent, or I plug a LLM model into my solution. These practices still stand, and I'm trying to approach these situations similarly. So whatever I create in Copilot Studio, I will source control and I will deploy with my CI/CD pipelines. So I have been presenting this like structure or context for my presentation, that we are working with a low-code platform which supports both people who don't have much experience with building apps, but we as pro developers, we can build amazing stuff quite quick when using Power Platform, because a lot of problems that we would have to solve on other platforms are abstracted. So we don't need to deal with that much with the boilerplate code, setting up security, handling identity properly, and mixing different storage models. So it feels very productive at first, but there are some gaps in the tooling which make it complicated or strange for developers who are used to working with other platforms. So for the past few years, I've been focusing on how we can make the workflow more productive by introducing some existing tools that we know and use as developers. I realized with my team that it is very hard to onboard new people on professional Power Platform development. So I started creating these patterns and scripts that I'm sharing with people, even for our own use, because we use it to train people on the CLI and how the things can work together and how we can plug it into an end-to-end process. Uh, so I think this is relevant even for the future, because if you look at the current state of the vibe coding tools and AI coding, uh, it has a lot of similar problems that human teams have, but it's just a lot faster. So if you've tried building an app with AI recently, with tools like Cursor, V0, Bolt, you can see that within the first hour, it's amazing how quickly you can get to a working application which looks nice, but then it starts getting bad really quickly. So it's just easier to write new code than bug fix the generated one. Uh, and I think with human teams, because I've been working with human programmers for quite some time, there are similar problems. They're duplicating code. They don't read the documentation. They're not trying to understand the whole code base. And we've built a lot of processes and things to fix that for people. So we introduced a low-code platform, which reduces the problem space quite considerably for inexperienced devs. We try to use declarative components, like creating a form XML for model-driven apps instead of like writing the whole interface ourselves. We use pipelines and continuous integration to do code reviews and some peer programming practices. In our IDEs in Visual Studio, we use language servers to help us refactor our code, so we don't make stupid mistakes by changing the code in a way that it doesn't work. We have design time compilation, so we can see that our code doesn't work before we deploy it. And the current state of the AI tools is not there yet. We don't see them applying all the things we have been building for years. And I think Power Platform can be quite interesting in this context, and I'm looking forward to how we will be able to plug it together. So if I oversimplify what we'll be trying to solve here today, we will have developer environments. Then we will want to integrate the changes from multiple developers into a single artifact, which we can deploy and test and run to see how the code works together. Then we want to run some tests and validate the solution, and then we want to move it to production. There are multiple ways how we can achieve that in Power Platform today. And with the new features that have been introduced recently, there is even more a more complicated decision making, which path to take as of now. So the native Git integration in Power Platform introduced an option to export the changes that you're making in your environment directly to a source control server. So I have a solution here, and if I if I make some adjustments to it, like, for example, creating a flow, I will quite quickly be able to take the definition, the code of the component that was created in the runtime, and I will be able to commit it to my Azure DevOps instance. For now, this is limited to Azure DevOps as a Git provider. So you can really choose your own or switch it to GitHub or other platforms, but this might be coming. So let's do a quick flow here. And the format, how the artifacts are now persisted, has changed as well. So in the past, you used solution exports and solution packager, which unpacked the customization XML file into files and folders, so you can read it more easily in the source control. This has changed a bit, so there is a different structure in the files and folders, and we also switched to using YAML format over XMLs. So you can see that I hooked up my environment to a branch in Azure DevOps on the Git server. I can either bind my environment to source control with all the unmanaged solutions that I have there. So every new unmanaged solution will get committed to the source control, or I can select more like selective way of binding individual solutions to individual folders in Git. So I will have more control over the structure of the repository. So you can see here that I made some changes, and here there is the flow that I just created. And if you're familiar with how unpacked solution components work, you can see that you can already see that there are some differences here. So if we look at the source code structure, you can see that we have got a new solutions folder. So unfortunately, that's the same for solution binding and environment binding. So you will always have this solutions folder within your solutions folder if you're binding per solutions. But if you're binding the whole environment, this is quite useful because you will see all the unmanaged solutions tracking components which belong to them here in this folder. So that's a brief overview of the native Git integration in the live environment. So if we compare it to how we used to do it with the new way, we used to import-export solutions. Now with the direct integration, it uses the same import-export handlers on the Dataverse side, but it is much faster because it skips the solution packager and the compressed archive step. So committing and pulling changes with Git to bring modifications to your environment is much faster now. We lost the CDS Proch file, which was scaffolded by PackCLI previously. That was helpful for the build process, because with this file, you could build solutions with MS Build. This is a common way, for example, for .NET projects, how they're built. And it was calling build targets with solution packager internally. So this is not there now, but Microsoft is working on introducing a way how you could build those unmanaged solutions in your own pipeline outside of your Power Platform environment, so you can ship it to the test environment in production. Because the native Git integration, it's meant to be used for dev environments only. So this is not for moving changes across environments, because it's completely unmanaged, and there is still the same structure for moving solutions between environments, which, for example, Power Platform pipelines are built around. So a quick overview. So we can now do it directly from the browser. We can have one repo tracking all unmanaged changes done by us. We even have API endpoints to automate hooking up environments to a Git repo and performing the pull and commit operations. But we don't yet have a way how to build a functioning solution which we can import to other environments from the source. So now we need to hook it to another environment, pull the changes there, and then export the solution as managed, and then import it to other environments. That's how most people have been doing that anyway, still till now. There are still some components which are not supported. There are not that many of them, but for example, data flows, they were not ALM friendly before, they are not now. But if you look at the component type code, you will be able to say that every component type with a code greater than 1000 works with this, because it's on the new solution framework. So it's not part of the customization XML, and it's just different from the old components. Canvas apps and data flows, they're somewhere in the middle between the legacy components and the new components, so they're not working as the rest of the components, and most of the important legacy components are there now. If you're advanced, you might know things like entity maps for mapping attributes between entities when converting leads to opportunity, for example. So this is also not part of the Git integration as of now. So if you need these, stay away for now. So now let's have a look at Power Platform pipelines. So if I wanted to deploy my solution to a downstream environment, I also do have a native experience that I can use. So I can take a solution from my developer environment and deploy it to other environments here in the Pipelines tab. And how this works is that there's a special environment in the platform which runs a bunch of plugins and stores the solution artifacts, so you don't have to store them in SharePoint and do this manual versioning. What it does when you hit deploy here, it exports the solution, stores it on the environment host, and then you can initiate deployment to other environments. And we do have some extensibility hooks here, so we can technically call our own operations which are blocking before export, before import. So there is technically an option to extend this and make it behave like a true CD pipeline, but it's not my preference. Another important thing to mention here is that it's still now built around individual solutions. So you're moving solutions individually between environments. So if you do have any sort of sophisticated segmentation strategy, this will not make it easy for you. So it cannot yet work with package deployer artifacts. So if you're using package deployer tools to combine multiple solutions and move them between environments as one deployment artifact, this is not there yet. But there is a hack that I will share with you. If you look at the Power Platform catalog, it can work with package deployer packages, and you can submit your package to the target environment as a binary file, and it will spin up the package deployer service and do the deployment for you. So you can make your own simplified experience and leverage Microsoft deployment process. But we'll need to move to the next topic now. So overview. We don't have code components which need to be built, sorted out here. You can do that through the flow extensibility, but it's not very convenient and nice. And if you want to customize the deployment process further, there's not much you can do, but it might work fine in your case. So here you can see how the extensibility is done. You can create your flows, which are triggered on Dataverse SDK messages. So you can override the behavior. And here is a sample of configuration that you can do on the Power Platform pipeline host to enable this extensibility. So here is how you can hook into the process. Okay, so I will need to move to the demo soon. Before we do that, I will just share some quick information for you to understand what I will be doing. So solutions in Solution Framework, they have got two types. Unmanaged, this is what you work with on the development environment, and the managed type. That's how you distribute your changes in your application, because then Dataverse behaves differently after you import it. So you can uninstall the solutions, you can layer them, and you can lock modifications to the components you're deploying to the target environments. I have mentioned the package deployer tool. So there are Dataverse packages which you can use to combine multiple solutions to a single zip, to a single artifact, and you can add your own code which will be handling operations before, during, and after deployment. So I use this heavily for enabling flows, post-deployment, migrating data in the database, and doing any sort of post-deployment steps that I need to automate. You can either do that manually in pipeline, or you can use package deployer tool to introduce your own C# code, which is executed as part of the deployment. Then monorepo is a term for combining multiple projects and assets in a single file system folder where a Git repository is initiated. So this is my choice. This is my preference. I try to have the customer projects in a monorepo way, built in a monorepo way. So I combine all the assets that I work with, those solution component declarative types, even those imperative types like PCFs and plugins. I like to have them in a repo. So I have a unified build process and versioning strategy and deployment model. I use some tools in my process. So we're leveraging .NET CLI, which we're using for building solutions out of artifacts, building plugins, building Webpack bundles for scripts which run on the form. We use native .NET targets to execute tests or publish the artifacts or create a published version of those artifacts. We also leverage PackCLI, which is a first-party native experience for working with Power Platform artifacts on your local machine or in a pipeline. If you're running Power Platform build tasks in Azure DevOps, they're also using PackCLI under the hood. And it's also useful to combine it with Azure CLI if you're working with Azure DevOps, because there are extensions which can automate some work with Azure DevOps. Because there are some pieces missing, I created these two repositories where I contribute some of the examples that I'm talking about. So if you're interested in this, you might want to inspect these repositories. And there are issues and pull requests for incomplete features. So also make sure to look there, because there is still some work left. If someone wants to help me, I'll be glad to accept contributions. Now, the last slide before the demo. We will separate the dev process into two loops, let's say. So the first one is what you usually do on your local machine when you're working on your tasks and you want to be productive there. And then you have the outer loop, which happens on the CI/CD server like Azure DevOps, where you integrate changes from multiple people and you run some checks which make sure that the the code base which was created as a combination of multiple change sets actually works. You can test it, you can release it and deploy those artifacts. We will be heavily focusing on the setup part, how to configure your custom DevOps environment in order to enable this process. Many of these things rely on customizing solution files. This is not recommended. Treat it like that. Here is a link to the repo with the demo that I will be showing. I will present this slide again after I finish, so you can check that yourself. So after you look at the repo, you can recreate the same state that I have here based on the README, and I will use VS Code snippets to show you some steps that I will perform to set up my environment and inner loop. So here I have listed some prerequisites of what the demo uses. We'll not get into detail right now, but this is what you need to set up on your machine to start building. I will just point out this last part, that there are multiple flavors of the PackCLI that you can install. if you want to use package deployer and configuration migration tool, make sure that you install it through the MSI file, because it downloads these additional tools, and some of the parts of the demo rely on that. So okay, so let's get into it. We will start with initializing our Git repository. So Git tracks changes you make to files, and it can track pointers to those points in time, and you can do that locally on your machine and synchronize that with a remote server. So I'll just initiate this repository, and after I do that, you can see that my VS Code will start tracking changes that I have made here, and I can commit them with some messages that describe what I have changed. Next step will be introducing a file which lists what I want to ignore in my repository. So I have some snippet files, scripts, things that I don't want to share with others when I change them. I'm also introducing a Visual Studio solution file. This is not Dataverse solution file, but if you're .NET devs, you might be familiar with this one. It tracks all the projects you have got in your repository. So if you run .NET Build or .NET Publish in the repository root, it can locate the things it is supposed to build. And you can use Explorer view on top of that, but this is not necessary. I use this to simplify my pipelines. You also need to patch the CDS project files which are generated by PaxCLI in order to enable this. You can see how that is done in the templates repository if you're interested in doing that. Next step is that I will create a package deployer project. So this is a .NET project which lists all the solutions, Dataverse solutions, as references. And when I build this .NET project, it pulls the resulting solution zips, and it compiles them into a single zip file. And it generates an import config file. This is important. This is where you list the order in which solutions are deployed. You can override some behavior if you want to, upgrade or update the solutions during import. You can include configuration migration tool package if you want to move data between environments. And there is also a C# class prepared here, which implements import extension, and this is what you can use to run your own code, override decisions during import and do any sort of post-deployment automation. Okay, next step is that we will commit the changes we have created. So here in the source control, after git ignore is applied, you can see that I have introduced some new files. So we will commit them. Now. We're including a commit message. And the next step will be about creating or setting up Azure DevOps instance. So I have scripted out the creation of a Azure DevOps project and repository. So if we run this, we will jump into browser and we will see our Azure DevOps project created. We'll see a lot of authentication prompts today. Okay. Something is going on in the background. I prefer to use Azure DevOps because I like the CLI, and there's a lot of support for things that I'm using. Is there anyone who runs on GitHub instead? Okay. Yeah, I think the day will come, but I'm still sticking to Azure DevOps. So yeah, we have a project here. We can track our work, our source code. We can automate deployments and builds and test process. We can use other features of Azure DevOps now, and we will move to the next step. And that will be creating a branch policy, because every change that we implement should be done in a user or feature branch where you separate your change set from others, and after you're done you will initiate a git merge operation where you can resolve potential conflicts. Uh, and to make sure that other people don't commit directly to the main branch of the project and that there is a code review process, you can protect your branches by setting up some policies. So here, for example, I set up a policy that nobody can merge into the main branch unless there is at least one reviewer who checks the code. So I created the policy here. And I could technically do all of this in UI, but to make it fast, I scripted it out for you so you can replicate it step by step yourself. So now I will be creating a pull request, and that's a record on the DevOps side, which tracks the requests for merging changes into other branches. And you can see that here in this UI, I can have some description of what I have changed. I can include reviewers that could be done automatically by a policy. And I can set up some conditions. So for example, if I want to run automated tests, I can block the merge unless the tests are successful. So this is what I can do here in the pull request UI. And I can also see all the changes here, and I can collaborate with colleagues and discuss the code and possibly raise some issues so the original author can fix that before we merge it with others. Oops. So we will approve the pull request. We can do that in UI as well. And after the pull request is merged, we will change our local branch. This is what you can see here at the bottom, that we are now switched back to the main branch where the latest change is, and we pulled all the changes from remote to our local repository. This usually needs some delay between those steps because this takes some time to process on the DevOps side. So I will run this again. And now we can see that we don't have any local changes. We are on the main branch. We can continue. Now we will set up our environments. So we should have a developer environment where we will, introduce the components, make some changes, test our local change set. So this command will initiate the creation of an environment in Power Platform. You can see that this is a developer type environment. Every user has got 3 free developer environments, so you don't need any licenses to do that. Although some tenants block creation of developer environments, but this is very useful thing to do. If you have large-scale deployments and development teams, nobody checks for which users claim these environments. So if you need to create an environment automation process which deploys nightly builds and have them ready for developers when they come to work so they can work with the latest CI build. You can just create a few dummy users, spin up a couple of environments and have a flow or any sort of automation, pre-provision those environments so they're ready for developers with the latest version of your application when they come to work, start working on the new change. So now we can see that we have a live environment. Next step is that we will connect our CLI to it. So I usually prefer to first clear all the connections so I don't confuse customers, environments, things. So we will wipe authentication tokens, and then we will connect to the dev environment we have just created. And we can be maintaining multiple authentication profiles, so so there is an option to switch between them, but it always happens that people confuse those authentication profiles, so be very cautious about that. So we will also provision a test environment, which we will be using as our deployment target. So the same process here. We will introduce a new authentication profile for the UAT environment. And we need to make sure we switch back to the original profile because this pack out create switches the active authentication profile, and we need to make sure we are only working against the developer environment, not any downstream environment that we might connect to from the CLI. Okay. There are three operations which take long in this process, and that's creation of environments and doing import exports. Everything else is quite fast if you do it locally. So here I will be adding a test user to the environment. So because I do have UI test automation in my pipelines, I need to include the test user under which the tests will be running interactively in the environment and assign them a security role so we can access that under that environment. I will be adding it to both developer and test environments. So you can use this quick command instead of doing that in Power Platform Admin Center. And what is nice is that if you include the environment parameter, it can switch the authentication profiles based on the URL. So that's convenient. Okay, it is stuck here. I don't know why, but we don't have time. Oh, okay, it's finished. So next, we will create service principals. So these are Dataverse users which are not interactive. I need them for two purposes. One of them is deployments from pipelines. So when my pipelines authenticate to the environment, if they want to import a new solution, they use service principal, which is an identity in Microsoft Entra ID, which represents an application or a service. So I'm generating the service principal here. You can technically do that through Pax CLI as well. The problem there is that it requires you to have Power Platform admin role in your tenant. That's not a standard in enterprise environments. So instead, you can use Azure CLI to create the service principal, and then you can assign them to the environment the same way as we assigned users with this additional switch. So I have added users. We can now go to the Power Platform Admin Center and inspect the configuration we created. So you can see that I have a dev and UAT environments here. And if I go to server to server apps, I should be able to see my two service principals, and there is just one. Interesting. But this is what we created locally. Okay, let's move on. So now we will set up pipelines. So we will start with creating local definitions of how those pipelines should work. So I'm creating a new branch locally that I will be working on, where I will introduce the pipeline definitions. So you can see that I created a folder with pipelines here, and I can use my snippets to fill in the content now. And these pipelines are very simple because I'm using package deployer. So it pretty much does three things. It calls .NET publish on the repo, or specifically on the package project here. Then it takes the build package zip and it publishes it as the pipeline artifact so other pipelines can consume it. So this is how the build pipeline, how simple the pipeline for building can be. My deployment pipeline is also very simple. So first it downloads the artifact we created in the build pipeline. Then it installs Power Platform build tools. That's a wrapper for PAC CLI for build agents for Azure DevOps and GitHub actions. And we are using deploy package task, which here uses our service connections, that service connection that we will be creating, and it just imports the package to the target environment. I also have a test pipeline here, but we don't have time to dig into that part. I'll just create it. And now we have our changes here. We can see what we changed, and we will again create commit, push it to the remote, and create a pull request. So git commit. Now it's pushed to the remote Azure DevOps server. Now we'll create a pull request. And I will approve the pull request because I can be a reviewer, but that should not be the case for your developers. We will wait because we set the autocomplete. The pull request will clean up the branch after it is merged, and it is automatically merged after all reviewers vote that they approve the change. And once the merge is completed, I will sync it back to my local machine. So now I have the latest version, and in the main branch again. So now we have pipeline definitions in our Azure DevOps, but these are just files, and we need to make pipelines out of them. So that's also a thing you can do through CLI. So there is a command which can turn your files into actual pipelines. I'm using skip run now because I don't have anything to build and deploy at this point. And if we look here to the pipelines section, you will see that I have 3 pipelines here created with no runs yet. I have 2 minutes. I don't think I will make it. So the next part, it deploys, it updates the pipeline definition files with some IDs that you need to have there. So I have some placeholders for environment and pipeline IDs. So that should update it in the file. And we will merge that as a pull request again. I will need to sync the changes locally before proceeding. And now, important part, we need our pipeline to authenticate with our Dataverse environments. And there is a relatively new thing called Workload Identity Federation in Entra ID, which saves you the trouble of handling secrets. So you can use tokens issued by Azure DevOps and trust them on the Dataverse side. So what I created here is a service connection in Azure DevOps, which then is federated with my service principal that is deploying to Dataverse. I can't get into the technical detail, but if we look at the DevOps instance, you should be able to see the resulting service connection here. Yeah, something failed. So you would be seeing a Power Platform service connection here, and now we have all the setup we need, so we can start developing. All right. So I do have automation here for generating a Power Platform solution, which has all the patches that I need in order to work with it in my repo. This calls pack solution init internally. I also am initiating some Dataverse tables. I'm adding references to the package project so I can build everything together, and that should show you how how he can scaffold some components locally. And the most important part is still running, so I will terminate that so we can continue. Here is how you can work with your local environment. You can import the solution that you build locally, and then you can make some changes on the live environment and sync them back to your local repository. So you can source control them. And what is nice about this approach compared to native Git integration and Power Platform pipelines is that you can, for example, introduce plugin projects here and add .NET references between the solution project and the plugin project. So when you build the plugin project, it first builds when you build a solution project, it first goes and builds the assembly from the plugin project. Then the result is pulled into the solution, and then the solution is deployed to the environment. And you can do the same for PCFs and scripts. So if your custom controls, they need to have a bundler, so they need to have some sort of compilation. That's something you cannot easily achieve in Power Platform pipelines, but you could be adding other project types here. And in the online repo, I'm sharing some examples of how that can be done for other component types. So that's it. Here is where you can find the demo, so you can inspect the snippets. Sorry. And I would like to close it off with inviting you to a conference focused on this sort of topics. So if you really want to get to this level and set up your DevOps game and professional development practices, we'll be gathering again in February in Prague. And if you're interested in what we are building, here's another information. I will share the deck, so you will see it. You will see it there. Thank you very much.